How do scientists predict long-period comet trajectories? Imagine trying to predict the path of a tiny snowflake drifting through the sky, but this snowflake is a comet traveling 4,000 or even millions of years. That's what scientists do when they figure out where long-period comets will go. These comets have orbits that last more than 200 years, and their journeys start way out in the distant Oort cloud, a huge shell of icy objects surrounding our solar system. When a comet gets nudged by gravitational forces from nearby stars or the galaxy itself, it begins its long trip toward the inner solar system. Scientists first spot these comets using telescopes, often when they are still far from the sun. They carefully record the comet's position in the sky over days, weeks, or even months. These observations are very precise, often using data from space telescopes and observatories on the ground. They compare the comet's position against known stars, a process called astrometry, which helps determine exactly where the comet is and how it's moving. Once they have enough data, scientists use the laws of motion and gravity, originally described by Isaac Newton, to figure out the comet's orbit. They put the observed positions into computer models that simulate the gravitational pull from the sun and planets like Jupiter. These models also consider tiny effects like radiation pressure from sunlight, which can push on the comet's tail, and outgassing, where the comet's surface releases gas and dust that can nudge its path slightly. The more observations they gather, the better their predictions become. Early on, when only a few measurements exist, the comet's future path has a lot of uncertainty. As more data is collected over time, the predictions become more accurate. Because long-period comets may have traveled 4,000 or even millions of years, small errors in initial measurements can lead to big differences in where the comet might go in the future. That's why continuous monitoring is so important. Key terms like perihelion, which is the closest point to the sun, and aphelion, the farthest point, help scientists describe the shape of the comet's orbit. Many long-period comets come from the Oort cloud, and when they are disturbed, they start their journey inward. Predicting their paths is essential for knowing if a comet might come close to Earth, which helps with planetary defense. It's also vital for planning space missions to study comets up close, using spacecraft that can follow precise trajectories, sometimes with gravity assists from planets to reach their targets. All of this work requires international cooperation, with observatories around the world working together to track these icy visitors. The science behind predicting comet paths is complex, but it's driven by a simple goal: to keep Earth safe and to learn more about the objects that share our solar system. By understanding how comets move, scientists can better prepare for potential encounters and unlock secrets about the origins of our cosmic neighborhood.